Today we're going to work on finding the volume of a sphere. So the volume of a sphere is 4 pi r cubed divided by 3. There's no height anymore because your height is actually your radius. That's why we have an extra radius now, radius cubed instead of squared. So what we have going on here, we have to find the volume or the radius of the sphere. So what we have in this first one is we're given the radius is 3, and that's all we need. Oh, I'm sorry, the radius is 4, and that's all we need in order to solve these equations. So I'm going to write my equation so I can start memorizing it. It's 4 pi r cubed divided by 3. So once I start plugging it in, we're going to get our answer. So I'm going to plug in my radius, so 4 pi and then 4 cubed divided by 3, and we're going to use order of operations to start solving. So in both the parentheses and exponents, that kind of goes hand in hand. So 4 cubed is the same as 4 times 4 times 4. It is 64 divided by 3. So I rewrote it, simplified it. Now I'm going to do 4 times pi, or 4 times 3.14, to start simplifying our numerator. And what I get is 12.56 times 64 divided by 3. So now I'm going to multiply it by 64, and then I'm going to divide it by 3 to get my final answer. Now they do say to round it to the nearest tenth, which is 1 decimal place, which we will need to because I got 257.9 centimeters cubed. Please remember to label. And that's what the volume of this sphere is. The next one is a little funky. It says that we need to find the radius because we're given the volume. So what I'm going to do first is write down my equation. Volume equals 4 pi r cubed, all divided by 3. And I'm going to plug it all in. This time it's kind of funky because we have 288 times pi as the volume, so they didn't multiply it out, they have the symbol, equals 4 pi r cubed divided by 3. Now, in this situation, because pi is still a symbol, I'm going to keep this pi as is right here, and I'll explain what to do with that in a minute. I need to start getting my r, my radius, isolated by himself, so I'm going to move the 3 first. This 3 is disrupting this entire side of the equation. He's dividing, so I'm going to use inverse operations, and I'm going to multiply. So I'm going to multiply both sides by 3 to cancel them out. So when I do 288 times 3, I get 864 pi, keep that pi symbol there, equals 4 pi r cubed, because that 3 is now gone. Now, this 4 and this pi are both multiplying to r because they're all stuck together. So I'm going to divide by 4 pi. And yes, you can actually divide by the symbol. So this is how it works, guys. When you are dividing and there are two symbols there's pi over pi, they cancel each other out. That's why I decided to leave pi as is instead of multiplying it out. So the pi's canceled out. Now I just have 864 divided by 4. I get 216 equals r cubed because the 4 pi's canceled each other out as well. Now, r cubed has an inverse operation, okay? To do the opposite is called the cube root, and it looks like the radical with a 3 there, okay? So let me explain this for a second. We have square roots, right? So if we had 6 squared, that becomes 36. The inverse operation of this, or to undo it, would be the square root, which is the square root of 36 is 6. So they undo each other. So if we're doing the cube root, we are going to take, if we're doing a cube, we're going to do the cube root on how to do that. Now, if you do not know how to use the cube root, you can ask me in class, and I can show you how to do it in your calculator. But when you do the cube root, you end up getting the answer of 6 inches. And that is your answer for the radius of the sphere. Go ahead and try the next two on your own. They are exactly like the previous example, so you're finding our volume in the first one, and hence they're giving you the diameter, and then you're finding the radius of the second one. Keep in mind that they kept pi as a symbol, so we should do that as well. Come back and check your answers. So after doing all of the mathematics, you should have gotten 2,143 and 6/10 cubic feet for the radius. or I'm sorry, for the volume of that first sphere, and then your radius should have been 3 meters for that second sphere. Our word problems this time involve composite figures. That means there are two figures that come together. We've worked with this with area, now we're going to do volume. So they're saying a hemisphere is 1/2 of a sphere. The top of a silo is a hemisphere with a radius of 12 feet. What is the volume of the whole silo? Round your answers to the nearest thousand, not thousandths, thousand. So this silo actually has two things. The first is a cylinder, okay? And then we have this hemisphere, so that's 1/2 of a sphere. So I'm kind of separating them out. Now they said that the radius of this hemisphere is 12 feet, okay? So I'm going to kind of label that. I know it's not drawn very well. Now, if the radius is 12 feet, guys, that also means that this part is 12 feet high, which is going to help us find the height of our cylinder. The cylinder has the same radius as the hemisphere because they're the same object. But if I subtract the 12 from this 52, the height of the cylinder ends up being 40 feet. So the height of the cylinder is 40 feet. So what we're going to have to do, guys, is find the volume of both of these figures and then just add them together. So for cylinder, we have volume equals pi r squared times height. It's the most basic volume equation that we have. So we have pi times our radius, which is 12 squared, times our height, which is 40. We're going to start simplifying. Pi times 144 times 40. Go ahead and multiply it all out. When we do so, I am getting 18,086 and 4/10 cubic feet. So that's what I got for that cylinder. Now we have to do the hemisphere. A quick reminder, it's 1/2 of a sphere, guys. So what we're going to do is we're going to find the volume of our sphere, which is 4 pi r cubed divided by 3. We're going to do all of that first, so I'm going to put in parentheses. Then we're going to cut it in half because we're going to cut the sphere in half to make that hemisphere. So we just need our radius to plug in, which is 12. So we have 4 pi 12 cubed divided by 3. We're going to do all of that stuff first, then divide by 2 to cut it in half. So 12 cubed is 1,728 divided by 3. Okay, and then after you do all of that stuff, then you're going to divide by 2. So when I find the actual volume of that whole sphere, I'm going to do 4 times 3.14 times 1728, and then I'm going to divide it by 3. What I end up getting is 7,234.56. But then, remember, that's for a whole sphere. We have a hemisphere here, so we're going to divide our answer by 2. I end up getting 3,617.28 cubic feet. Unfortunately, we are not done yet. Because we have the cylinder and we have the hemisphere, we need to add them together to find our final answer. So when I add these guys together, I get 21,703.68 cubic feet. Now let's go back to what they're asking for us. They want us to find the volume of the silo. Cool, we did that. But then it says round your answers to the nearest thousandth place. So what that means is our answer is going to round up to 22,000 cubic feet, and that is our answer. Always look to see what we're supposed to round to. Go ahead and find the composite volumes of these two figures on your own. This first one, we have two hemispheres that are actually creating one sphere. So you're going to have one sphere and a cylinder that you're going to have to find the volumes for. Then you'll add them together. A quick hint is that they're 2 inches on each side right here because they're saying the radii are 2 inches. So think about how if you take off 2 from each side, what the height of your cylinder will be. It won't be 8. The next example you guys have is a cylinder and a cone. So go ahead and find the volumes of those and then add them together. Check back with your answers. You are going to round to the nearest tenth, 1 decimal place. All right, so these are the answers you should have gotten. I put the volume of each of the figures that we found, whether it was a sphere, cone, or cylinder. Then I added them to get my final answer. Make sure you are always labeling. Make sure you're rounding to the right spot. Make sure your answers are correct.